Yeah, so the only other topic today is finish the comment or discussion of the, is it being recorded, I guess? Okay. So somebody can remind me, where did we stop last time? I totally forgot. Yeah, it was towards the end of the multiple linear regression. I think we talked about, right, I think we talked, yeah, we'll probably run here, I think. Like say, now we put all of the predictors together, right? One of them, so 3 predictors in this case. One is a continuous one, the other one is binary, the third one is a categorical, but we put all of them in the binary in the reference, compared to the reference. So for the rest, it's mostly just about how to use JAGS to do it. So I'm just going to cover this quickly. If you have more than one predictors, the subjective prior that we did before, as well as the conditional means, might be challenging to do. So what we're going to do is go back to the first setup that we have, just try to give a weakly informative prior for all of the parameters, and just let the data decide to see how the result's going to be. So remember, every time we're trying to do this weak informative prior, we're going to assume every parameter is independent from each other. That's why for beta 0 through beta 7, we have 7 independent normal priors, or 8 in this case, 8 of them. Each of them is normal mu j and sj, where j stands for the index for either the slope or the coefficient for each of those predictor. And sigma, similarly, is 1 over sigma squared to follow a gamma AB, and typically we do gamma 1, 1. Okay, so that's the setup that we saw before. And you can see here, the example that I gave for the normal, univariate normal for the regression coefficient or the slope. For most of them, we're using just normal 0, 1. And that is centered at 0 and then with some deviation. Okay, so in this case, we standardize any continuous outcome or predictor. So we standardize the log expenditure, which is the outcome, and log income, which is the one of the predictors. It is a continuous predictor. And so I included some code to do create indicator variables for those categorical levels. So it's a little bit tedious, but I included here, and I think the detail you will see it when you look at the R file for this lecture. I think I included all of the possible ways to do it. And you do that for the rural variable, which make it into a binary. And also for race, you're actually going to end up having 5 indicator variables, because it's a categorical variable with 6 levels. So if you create indicator variables, binary ones, you're going to have 5 of them. All right, a bit very long over here, but this is similar to what we did before with the simple linear regression. Now we're working with the multiple linear regression. You will have all of the predictor ready for each of the observations. And also the priors that we give over here for beta 0 to beta 7. And lastly, the inverse sigma squared. So this, I think, overall will look similar to what we did before. And I know some of you are doing multiple linear regression for your projects, so I think you have seen this or played with this already. So what I can say is an extension of what we did for the simple linear regression. And this is code very familiar, hopefully by now, how you can pass the data and the hyperparameter values to JAGS. And you do the Y, you do each of the X in this case. And don't forget the number of observations, which is capital N in this case. So this is where we create this B_data list, where we have all of the Y, all of the X's, as well as all of the hyperparameters, the values of them, all of the mean and variance of standard, sorry, precision in this case, because it's for normal, and then A and B, both of them are 1. If you want to get reproducible results, you can use this index function. Okay, I think many of you are doing that. That was grading the midterm too. So I know most, yeah, pretty much everybody knows how to do this, which is good. And lastly, make sure that you monitor the parameters that you want to monitor. In this case, it's beta 0 through beta 7, and then that's sigma. And I'm doing it for one chain and only thinning for one, just to see how things go. So yeah, so this is the output for the summary. There are some of the betas are negative, as you can see, some of them are positive. So if you want to check each one in particular, you can interpret each one carefully, looking at which coefficient you're working with, and then which level, say, for the categorical variable you're working with. So you can talk about comparing to the reference level, what is the change once you go from the reference group, which is the white group, to any other race group that you're working on. And so that's the interpretation, and beta 0 is the intercept. This is quickly just shows a couple of parameters to look at its diagnostics. This is for beta 1, and I think this is for beta 2. And overall thinning of 1 seems fine. And we can actually see that from here as well. Many of you are looking at effective sample size. That's the important thing to check. And for this case, only a few, maybe a little bit lower, but definitely way above what we need. So thinning equals to 1 seems to be okay. And this is the case for sigma. Okay. And lastly, I mean, these are just some other ggplot script that I thought maybe will be useful for you in the future. This is the case that, remember, we have 9 different parameters, 8 betas, right, and 1 sigma. So this is the case that I'm trying to plot the posterior density for all of them on one plot. And sorry about all of the squeezed results. I just had to push everything in the slide to see it. But the R file, the markdown file that I posted, does not have the restrictions, so you will see a better plot over there. Overall, what this is showing, as you can see, is 3 by 3, and they all have the same scale on the x-axis and the y-axis, right? Yeah. So in this case, remember, beta 0 through beta 7, we use the same normal 0, 1 prior for all of them. Okay. But now you can see how the posterior is different, especially now. So the next page here, so hard to see, but the dashed line, they are the prior density. Okay, so I'm adding the prior density to each of the posterior draw or posterior density that we have for each of the parameters. Remember, in the past, when we're only working with one parameter, we looked at the prior and the posterior on the same plot, right, and tried to see how they contrast to each other. This is so if you look at the code that I've posted in the markdown file, you will see how you can do it for all of them at the same time if you want to plot all of them on the same graph. Okay. This might be helpful overall, especially for beta 0 to beta 7. We use the same normal prior, but then you can see how different those posteriors are. And yeah, so again, if you want to do inferences about multiple linear regression, you can do something like what we did for the simple linear regression. You can do prediction, you can do posterior predictive checks. You can also look at the expected response if you want. And like what we did for the case study, you can try with different priors to see how the posterior summary is going to change or how those impacts will be on the posterior inference. So those I will just leave it open-ended. And if you ever run into any of these types in the future for your other coursework or other projects, feel free to try those things. And yeah, I think that's all I prepared. Any questions about the linear regression in general, or anything else about course?
Could you give us a little more information about the video?
Right, okay, yeah, so sounds good. I will do that. So let me